All right, guys. Good day and welcome to the GMAETS 41's YouTube channel. So, I've got something wonderful I'd like to share with you, friends. That's about the workbook of the friends in UNIZIK, 100 level student. So, this is a combined solution of your Math 101 workbook assignment, your Physics 101 workbook, and of course your Chem 101 workbook assignment. Yeah, there is a combined solution of these three courses, their workbook, for which you guys would be expected to submit, before your examination. And of course, you can see we've got your Math 101 Module 3. This is question 1 showing on the screen. You can see that. And of course, this question is based on AP and GP, as you can see on the screen. This particular question from Module 3, question 1, is a GP problem, geometric progression. All right. So you have the first term, which is equal to 7. You have the last term, which is 448. And of course, the sum of the first nth term was given to be 889. And the examiner requires that you obtain the second term of the GP. So you can see the work being done. And of course, this is something wonderful coming from GMAT 41, as you guys already know. Like I've rightly said in previous video that I've made, that GMAT 41 is here for you guys, right? No shaking, no time. You can always count on the GMAT 41, for I got your back. So I'm using this opportunity to invite you friends to join the GMAETS 41, become a channel member. All right, you can also register fully for the tutorial if you wish to join the physical tutorial on campus in UNIZIK. Okay, but then, like the workbook, the solutions will all be made available on the GMAETS 41's YouTube channel right here. Okay. And of course, becoming a channel member gives you access to all these solutions. Already, Module 1 of your Math 101, I had released it and it's out there on this channel for you friends to go through, okay, and enter them in your workbook. Like I've always said, I'm not a fan of just copy and enter. Please, you would want to read through what has been solved. Is that okay? Read through what has been solved, because you will need that as you prepare for your examination. Then of course, Module 2 is also out there on this platform. However, it's meant for channel members only, okay? And you can access it once you join the GMAETS 41's channel, at least from the Platinum's level above, okay? On this platform, the GMAETS 41 has the gold level, okay, it has the platinum level, and it has the diamond level. And please, I'm using this opportunity to appeal to you friends and encourage you, please, join the GMAETS 41's learning community. Become a channel member. There is so much to learn there. Is that okay? And remember, please, a whole lot of work goes into making these stuffs available for you guys. I must tell you, it's not easy, it's so challenging. Making sure that these workbook solutions are available, making sure that video lessons and your courses are also available so you can take them while you also study your textbook, very important. Go for lectures, right? You need these stuffs as well too. A lot of effort goes into it, resources goes into making sure that these stuffs are available for you guys. And what can you do to appreciate, the commitment of GMAETS 41s to your studies? I encourage you guys to support this channel, so that we can pull strength together. Become a channel member, all right? Become a channel member, and you are sure to get the best anytime, any day. The GMAETS 41 doesn't disappoint, all right? The commitment is absolute, it's 100%. All right, so this one is module 3, question 14. That's second to the last question of that module 3. And so, like I said, friends, please join the GMAETS 41's channel. All right, on this channel, you would see the join tab. Just click on the join tab, and please, I appeal to you, select from the platinum level above, okay, so that you can be able to access all the works available. On the gold level, you do not have this workbook there. You don't. Just very few stuffs you have there. You want to really enjoy much of what we have on the GMAETS 41's channel here on YouTube. Please consider selecting from the platinum level, the diamond level. Okay, what you're joining the channel for is worth it. I hope you know that it's worth it. So please support this channel, and of course you can be sure of getting the best always. Like this module 3 question 14 is extracted from trigonometry. Very interesting question. You can see you're given sin theta to be equal to the square of a minus 1 all over the square of a plus 1, and you are required to evaluate sec theta plus tan theta. Eventually, having solved this, the correct answer is A there. You can just go through. And then here we've got, works on Chem 101, all right? Introductory in Organic Chemistry, Chem 101. So this particular question is extracted from laws of chemical combination and stoichiometry, linked to limiting reagents. So you can see question number 9 on page 22. This question is based on limiting reagent. What would be the limiting reagent if you have a particular gram, that is 75 grams of this organic compound there. What's the name of this organic compound? Let's see, that should be 1,2,3-tribromoethane. 1,2,3-tribromoethane. Okay, 75 grams of it. The molar mass has been given already to be 266.72 grams per mole. So if this guy reacts with 50 grams of oxygen gas, all right, and the relative molecular mass of oxygen there is 32 grams per mole. Now this reaction follows this equation as given there. You can see the equation, all right. 4 molecules of that 1,2,3-tribromoethane react with 11 molecules of oxygen gas, and of course the products given, we have 8 molecules of carbon dioxide formed, 6 molecules of water, and of course 6 molecules of bromine gas. So you can see the solution there. The stoichiometry shows that 4 moles of the organic compound is being combusted, burnt by 11 moles of oxygen gas. And there's something about stoichiometry and limiting reagent. You don't joke with the reaction moles. Very important. That's the reacting masses and stuff like that. Don't joke with them. You need them so that from there to now guide you to know what else to do. I think the examiner here asks us in that workbook what would be the limiting reagent. That is, out of the 1,2,3-tribromoethane and oxygen, if these two guys react, which one will be the limiting reagent? And of course, in one of my videos where I taught the concept of limiting reagent, excess reagent, percentage yield, okay, actual yield also, and then theoretical yield, I explained the concept of what limiting reagent is. That particular guy, that reagent or reactant that will be consumed completely such that it will make the reaction to stop during the reaction. Once that particular substance is consumed in the reaction process, that reaction will stop. Okay, that guy is what we call the limiting reagent. And so if you go through the workings, you find out after converting the 50 gram, I decided to keep the reacting mass of that organic compound constant, and then check the value of it that will react with 50 grams of oxygen. And after that, you find out that at the end of everything, the mole of the organic compound that will react with 50 grams of oxygen, we found it out to actually be 0.5682. 0.5682 moles of that 1,2,3-tribromoethane. Now we have to convert that mole to mass so we can be able to do the comparison whether the mass of the organic compound that was supplied to us, if it's actually enough for the reaction or not. So to convert, you have this simple formula, number of moles, which is simply amount, is equal to mass over molar mass. And because applying that formula, you find out that the mass of that organic compound will be 151.6 grams. That is what is required to react with 50 grams of oxygen. Now, like I stated earlier, going backward from the question, you notice the mass of the organic compound available to us given in the reaction process is 75 grams. That is what was given. So let's assume you're in the laboratory. That 75 gram of 1,2,3-tribromoethane was provided, and it was said that that guy would react with 50 grams of oxygen. But then, after the calculation, we found out that the actual mass of the organic compound that would react completely with 50 grams of oxygen is 151.6 grams. So do you see, out of the 151.6 grams, you were given just 75 grams. It means if you start the reaction, the reaction, once the 75 gram is used up, oh my gosh, something's going to happen. You have 75 available to you. So once that 75 gram is used up in reacting with oxygen, the reaction will stop. But then, the mass that is actually required to react with that 50 gram of oxygen is supposed to be 151.6 gram. But then only 75 is available. So do you see that during the reaction, the whole 75 will be used up, and yet oxygen will not completely react yet. Oxygen will still be left. But you no longer have extra value of the organic compound to react because you need 151.6 grams of it to react with oxygen. So the whole idea is this. You can see the conclusion there. Are you following, right? That from calculation made, we need 55 grams of oxygen will require 151.6 grams of the organic compound. But only 75 grams of the organic compound is available. So it simply means that during the reaction, the whole 75 grams will be consumed before you start even talking about that 50 grams of oxygen. So the idea is the 75 grams of the organic compound is not enough. It's not enough. It will be used up during the reaction. And once it's used up, oxygen is still remaining, but nothing is left to react with oxygen. The reaction will stop. So you see, that's the whole idea of limiting reagent. So since the mass of 1,2,3-tribromoethane available to us, which is 75, is less than the actual mass required to react with the oxygen, we can now conclude that the 1,2,3-tribromoethane is the limiting reagent. All right, like I said, on this platform, the GMAETS 41 has got something wonderful, no time. Something great for you, friends. And I think in this present dispensation, to ensure that we get the best in our studies, platforms like this has to be encouraged. What do you think? Anyway, the GMAETS 41 runs both online classes and physical classes. For the physical classes in UNIZIK campus, for 100 level student, 300 level student, and 200 level student, okay? There are courses that I take them on. And of course, if you come to the GMAETS 41's playlist on YouTube here, you would see these courses there. Please support the channel, become a channel member. As said, you can join from the platinum level and above so that you get access to all the lessons and packages that are available for you. And if you're in UNIZIK, 100 level, 200 level, or 300 level, okay, let's talk about 100 level specifically. Our new friends, who just came in. You want to join a physical tutorial, what is holding you? And what are you contemplating? What are you contemplating? You really want to join a physical tutorial, please. Come to the GMAETS 41, okay? Come to the GMAETS 41. You'll be glad you did. Like I've always said, the only language I understand is first class. The road to first class is right here. Are you following, right? At GMAETS 41. Because here you'll be taught the length, the breadth, the height of things that you are learning. You would understand it such that if you go into the exam hall, you can't be dribbled by your examiner. And not to forget, when it comes to physical tutorials, like I've always said, the truth is sometimes one or two things may challenge your presence in that physical tutorial. Could be that maybe your practicals clash with the class, or maybe you are kind of weak some days after lecture, other things you want to go home. Now the GMAS 41's online platform helps to cover up in this aspect. So the whole idea is if you join the GMAS 41, register for classes, you won't miss any class. Yeah, you won't. Even if you're not present physically in the class, you can actually take our lessons online. On the GMAS 41's Telegram channel, you have your courses there already completely in video format and lesson note format with the course content, what the examiner expects you to know, step by step and well detailed. All right, friends already on that platform, they're enjoying it. And see presently that we're on break, this December break, our classes are going on 100% cool and students are learning very well. Okay, students are learning very well. Don't worry, I will show you something, even quizzes that we conduct based on the online classes taking place, all right, through our Telegram channel. Let me just show you something quickly. You'd love to see that. Okay, let's see a WhatsApp group here. WhatsApp group on this learning platform. So what have we got? Let's see. Okay, so trying to show you something. So you really have, a lot of fun. You'll enjoy learning from GMAT 41. This is one of the assurance you get always. And at the end of everything, you will be certain of blasting your first class. All right, so after our online class on circular motion, good, we've got these questions, exam focused questions, 10 of them. You can take a look. Okay, so you can see the questions. We are students. Now this is question number 1. An object moves in a circular path of radius 5 meters with a speed of 1 meter per second. Now what is the angular velocity of the object? And of course, based on what the student learned from the online class, like I said, the video lessons are fully all arranged accordingly on our Telegram channel. And once a student gets registered, you get access to that channel. Even here on YouTube also, you have a copy of that video. If you go through the GMAS 41's playlist, are you following? You're going to see that. You're going to see that video lessons on all these topics. Okay. But like I said, support the effort and commitment of GMAS 41. Please, easy for me, right? But I keep the momentum going, and by the help that comes from our God and helper Jehovah, I'll continue to sustain the momentum as long as there is life. Okay, but please support this channel. Become a channel member. As monthly, you will support GMAT with whatever you are able to. And of course, be assured that I appreciate that. So you can see the questions based on that online class. We've taken classes on Math 101, on stuff like sword during this break. So even while others are at home, we understand that it's break time. So going for break, ordinarily physical class is put on hold. But you see the wonderful thing that technology has done for us. And the GMAS 41, I'm not joking with the advantage of what we have from availability of technology. So you have this question: the diameter of circular disc is 10 meters if the disc makes 60 revolutions per minute. And then the centripetal acceleration is, we don't know. This particular question, let me now expose something. I played a trick on the friends, okay? I wanted to ensure that these students are confident in what they are learning. So this particular question, the correct option is not there. Yeah, and I did it on purpose. The centripetal acceleration here by formula is A equal to V squared divided by radius. And of course, we know that V, which is tangential velocity, is equal to RW, where W is angular frequency or angular velocity. If you actually play with that formula, you will get acceleration to be equal to RW square. Yeah, RW square. And if you solve for this, the correct answer to this question is actually 20 square of pi. That is 20 pi square in the unit of radian per square second. So that is it. It's been an interesting one, and we keep moving, right? We keep moving. No time. Classes will be ongoing online on GMAS 41's platform till we resume. You can see this question number 10. Very wonderful question, right? The position of a particle in circular motion is given as, you have the function there, RT, that's the position function, equal to 2 cos WTI plus 2 sine WTJ in meters. Right. Now, if the speed of the particle is 2 meters per second, now the examiner asks you to find the period and the angular frequency of the particle. So if you solve that based on the knowledge already obtained from the online class, and of course, you would have the correct answer to be D, 6.3 seconds and 1 radian per second as the angular frequency. So I'm using this medium to tell you that something great is happening. On the GMAS 41's platform, yeah, a student did wonders in blasting all 10 questions. And of course, a little prize was given just to appreciate the student. Like today, being, I think today is 28th of December. Not good at dates sometimes, all right? 27th of December. All right, today is 27th December. Yeah, we already have this class, Chem 101. You can see that the topic that we are taking today is on quantum numbers in Chem 101, where you talk about the concept of, the Schrodinger's equation used to derive the quantum numbers. The quantum numbers, there are 4 of them actually, and 3 out of the 4 are basic. We have the principal quantum number, we have the azimuthal quantum number, we have the magnetic quantum number, and the spin quantum number. The first 3 are most important. The spin is just added to show the direction of spinning of an electron. Then, of course, the students are also expected to take on principles of filling atomic orbitals. Okay. And these, you see these video lessons on the GMAS 41's Telegram. However, there is a copy of each of the lessons on the GMAS 41's YouTube channel. Yeah, that's right here. Go to the playlist and you check, you see those stuffs. Yeah, so the GMAS 41, we are committed to giving students the best. And you can always be assured of that, okay? You can always be assured of that. All right, let's see, we're going back to the next stuff. Think on about your workbook, okay? Don't mind me that I digressed, and of course, it's for you to know that I'm really here for you, friends. It's just something you want to be assured of. And, as I'm here for you, I'm appealing also for your support. So I will keep, moving. So I will keep moving. All right. Now the next question and course is Physics 101, because actually I've got 6 questions, 2 from each of your workbooks. The complete solutions of these stuffs are available. Yeah, the complete solutions. Math 101, your Chem 101, your Physics 101 is available on this channel. So you can actually make use of this channel to get the best you can in your studies. Remember, it's not easy. Soon the examination will just be ringing. So this is Physics 101, Chapter 6 on oscillatory motion, question 5. Very interesting question that your examiner has, given here. Quite interesting and fun. A 12 kilogram mass is suspended from the end of an elastic spring at rest and then released. Then upon releasing, the spring performs a simple harmonic motion, all right, with a period of 0.8 seconds. Now, we're given the amplitude of the oscillation to be 5 centimeters, and then the examiner requires that we calculate the energy possessed by the 12 kilogram mass. So you can see that. Interesting solution. So you need the idea of simple harmonic motion. If you look at what was given to us, but let me quickly point out this. When you're talking about simple harmonic motion, you're going to learn all of those in our classes as we move on, both in the physical class and in the online class. Meanwhile, take note, the physical class takes place in UNIZIK campus, all right? On campus, so you don't need to go anywhere far. I'm right there with you guys. Simple harmonic motion, when you talk about oscillatory motion, right? There are various forms of them. You have the simple pendulum, torsional pendulum. Again, you have a case where the mass is attached to a spring, and that is where this guy comes in, okay? So you can see the solution there. To calculate the total energy of this mass, the formula for calculating energy under simple harmonic motion is 1/2 Ka squared, where that K is the force constant, also called spring constant, elastic constant, or stiffness constant. And then, of course, that A is the amplitude. So for this question, the only thing that the examiner expects of you is get your K and then use your K to get the energy. A has already been given to us, amplitude, 5 centimeter. You convert it to meter by dividing by 100, you have 0.05 meter. Right, so you can see the work there. So the first thing to get your K, you need to use the period of oscillation. Period of oscillation in the case where a mass is attached to a spring is equal to 2 pi, then square root of mass all over the spring constant K. You can see the formula there. So solve for K, which gives 740.2 Newton per meter, and then substitute in that energy equation. Of course, you get the energy of that mass to be 0.93 joule. All right, so you can see that, and that's wonderful. So please, I'm using this medium to inform you guys to contact GMAETS 41, get complete solutions to your workbooks, Math 101, Phys 101, and Chem 101. But that is not all. You shouldn't just end in the idea of just workbook. You want to really learn. Study your textbooks, attend lectures. If you need further assistance, each of us, we know ourselves, right? You think that you need further assistance, you want to join tutorials, good. So here GMAETS 41 comes in, and you won't be disappointed, okay? You won't. So you can actually join our full tutorials, register and join us, and you will enjoy the classes. Concepts are being broken down. 1 + 1. You understand the full things, right? The way of solving particular questions. And then, of course, I show you the shortcut of how to deal with that in exam. Okay, let us look at others. This is also Chem 101. Like I said, I've got 6 questions for you, 2 from each of the courses. This one is on radioactivity, page 90, question 4. This question, very tricky. Yeah. In fact, based on this question, if you don't want to solve anything clearly, the correct answer to the original initial activity of the radioactive substance is 100%. See, the idea is simple. We are asked to calculate the initial activity of a sample that has decayed to 50% of its original activity after 10 years. So they gave you particular time for which this decay took place. Now they gave us the half-life again, T-half, to be 10 years. It simply means the normal time. There's something I call the normal time of decay. Just if maybe you have, let us say, okay, let's say you have 50 grams, for example, of a substance initially. You know, at certain time, that substance will decay. Let's say in five, okay, let's make it in years per se. Let me say in 2 years, some part of it decay. Let's say it lost 10 parts, so 40 parts will be left. You know, in 20 years, it lost another 10 parts, so 30 parts will be left. So all this decay is taking place in a given time. Now, you notice that I mentioned in 10 years, another in 10 years again. So it's as if every 10 years, that radioactive substance will be losing some parts, will be decaying. So all those times, I refer to them as the normal time, the standard time of decay. However, what if the thing reaches a special time called the half-life? That half-life now is when half of that guy has decayed. So if actually it had 20 gram initially, and then it had 50 gram, like I said, and then it loses half, which means 25 is lost, 25 is left. The time that thing happens is called the half-life. So if you look at what the examiner gave here, the normal time, 10 years for the decay, corresponds to the half-life, because they are all 10 years. Now we are told that we should calculate the initial activity of a sample that has decayed to 50%. Now, if 50% decays, the idea is that 50% will be left. Are you getting me right? Without solving anything. So if I know the original mass of that guy, all I have to do is just take 50% of it, and you get the final activity. Are you getting me right? Now, the initial activity in percentage is always 100%. It means complete. So for this question, I just smiled. I said, on a normal, in exam, if you're giving this, you don't solve anything. The correct answer is just 100%. And then by solving, you could see at the end, the initial activity A naught is 0.5 over 0.5, giving us 1. That 1 in decimal, if you convert it to percentage, you are going to get 100%. All right, don't worry. You're going to get access to all this stuff. And of course, in our classes, I'm going to break down all these concepts and see the 1 plus 1. This is question number 1 of Physics 101, chapter 1. Very interesting. So the examiner has got some good stuffs for you guys. So this is based on this equation, and the equation is the amplitude of damped harmonic oscillator. So we are asked to get the dimension of A. We are asked to get the dimension of A. Now I've decided to present this in a standard form of solving, step by step. But the truth of the matter is this question, to solve it, if you look at that A in the question, given A equal to A naught exponential minus, then you have small letter a t over m. Is that small letter A the dimension that they are asking of? And if you look at that small letter A times t all over m, so that a t over m minus a t over m together, they are the powers of that exponential. They are the powers of that exponential. So the quickest approach to dealing with this is remembering this very important point. You can put it down if you want, right? That the argument of any mathematical function, I repeat, the argument of any mathematical function, that is the value attached to the front of that mathematical function, is always a dimensionless quantity. That is, that whole thing, the dimension of that whole thing is equal to 1. When you talk about dimensionless quantity, all right, they are always equal to 1. I actually have a video lesson that covers that. For example, you have exponential minus at over m. So that minus at over m, its dimension, that guy is dimensionless. So all you say for a dimensionless quantity, if you take the dimension of that guy, to be equal to 1. So, but I try to show certain proofs and standards why that thing is like that. Okay, the argument of that small letter a there, together with t over m, all together, they form the argument of that exponential. And what do we mean by argument of that guy? You see, to get the value of that exponential, you must know what the power is. So the exponential takes that power. You impute the value of that power, then you evaluate. Think, for example, if I give you something like sine 5x, that 5x is the argument of that mathematical function sine. So if I say, okay, now get the dimension of that 5x, maybe that x rather. So all you have to do is 5x, make it equal to 1, then get the dimension of x, as the case might be. All right, you can check from that part of hence. Like if you're in exam hall, that is actually the part you should start dealing with in solving this question. All the other ones is just to explain why we get something like this. So it's going to be 1 equal to at over m. Notice that I dropped that minus. The reason is this: constant multipliers or constant divisors, when carrying out dimensional analysis, you don't use them. So if you have a constant number multiplying, you drop it. Are you following, right? That is why that minus is the same as -1 times A times T all over M. So you drop that -1, then solve on. Then of course the dimension of that small letter A is capital M times capital T raised to power -1. Then here we go. The next one, okay, I think that's it. That's it. And those are the 6 questions. Those are the 6 questions. Can still go through. Phase 101, Chapter 1, Question 1. Chem 101 on radioactivity, page 90, Question 4. Then back again, Math 101, Module 3, Question 1. Then Math 101, Module 3, Question 14. Yeah, then I've got Chem 101 again, page 22, Question 9, solution. It's extended to this part. And then Physics 101, Chapter 6, Question 5 on oscillatory motion. Alright guys, so have fun with this. You can actually transfer some of them into your workbook and, like I said, study them. It's very important, understand them. Then for full learning, if there is anything you don't understand there, okay, remember the GMAETS 41's learning platform is there. You can join our physical tutorials. You have that option. You can also decide to join us online and become a channel member here so that you can follow up with whatever update that I give here. Subscribe, turn on the notification bell so that once I upload any content, you will be personally notified. I repeat, remember to turn on the notification bell. Subscription is free of charge. Turning on the notification bell is free of charge, right? Then please go further. Appreciate this platform more, okay? I guess I'm doing something great, don't you think so? Yeah. They say that when a lizard falls and no one comments it, it will wag its head, commending itself, and it try. And I'm ready to still keep giving the best to you guys, right? So, go further, click on that join button, select any of the package convenient for you. Support GMAETS 41, it goes on monthly support. To get more access, are you following, and to all these stuffs here that I release, okay, please select from the platinum level and above. Select from the platinum level and above. And those that watch our video lesson on public domain like that, the ones I just released for everybody, because we have those videos specially for channel members. Are you getting me, right? That includes this your workbook as well, to complete solutions to them. So for those that just watch our videos in the public domain, those ones that are general, you can also appreciate GMAETS, right? You can. Yeah, you can do that. And how do you do that? You can choose to select the gold level package, okay, where you give your monthly support. Alternatively, you can use that thanks icon. Send GMAETS 41 a super chat so I can get a cup of coffee and stuff like that. Anyway, I don't know, do we have coffee here in this country? Yeah, but if you hit that thanks icon, right, you would see options that will appear. You see options that will appear. You can support the channel with anything that you want in appreciation for what GMAETS 41 is doing. Alright guys, do have a wonderful time. I just brought this out for you so that you will be aware that GMAETS 41 has your workbook solutions for these courses available. So what will you do? Get these complete solutions to your workbook on Math 101, on Phys 101 and Chem 101. Just register now, okay? You can contact me to make your registration. Otherwise, you can also become a channel member, all right? Of course, you will enjoy a lot from this platform. All right, guys, I'll be seeing you next time. Do enjoy yourself. And let me go and attend to my students because they'll be taking their exam focus quiz on the topics we are covering today in Chem 101. All right, take care of yourself.